Okay, so we finished that one and we're going on to second to last one. So, kind of going to check it the same way. Look for our end behavior models, our holes, our graph, and vertical asymptotes. So, if we factor our denominator, so we have x plus 2, x minus 2, we can see we're going to have a hole at x equals negative 2. So, a hole at x equals negative 2. And we have a vertical asymptote at x equals 2. And our end behavior model, so if we look at our degrees, our numerator is a degree 3, and our denominator is a degree 2, which means we have a top-heavy graph, and that simplifies to be x. So our end behavior model is y equals x. So I'm going to graph my vertical asymptote at x equals 2. I'm going to graph my end behavior model at y equals x, the line y equals x. And I know I have a hole at negative 2. So on this one, when it just is one single vertical asymptote and then an oblique or an end behavior model like this, your graph is going to be on either side of those, like in the window that fits it. So I would recommend graphing this one. This one's kind of weird. And then if you zoom out, you'll be able to see the whole graph because it's way up here and it's down here. So graph this one in your calculator. You could always test points, but something like this that doesn't have two vertical asymptotes would be a calculator type question. Okay, so then the last problem is analyzing this whole thing. So we want to find the intercepts, asymptotes, limits, at all of our vertical asymptotes, analyze and draw the graph of this. So first I'm going to do what I've done on the rest of them. So I'm going to factor this, which ends up being x minus 4, x plus 3. So my vertical asymptotes are x equals 4 and x equals negative 3. I think it's easier to draw in my vertical asymptotes before I decide what the domain is. So I'll draw those in. So x is equal to 4 is an asymptote, and x is equal to negative 3. And so my domain is going to be everything except for those. So negative infinity to negative 3, union from negative 3 to 4, union from 4 to infinity. My range, I'm actually going to wait on until I can see what my graph is. So if I look at my end behavior model, I have x over x squared if I'm comparing degrees, which means it is a bottom-heavy graph, which means that it has a horizontal asymptote at y equals 0. But I'm not going to write my range in yet, because horizontal asymptotes are often true for the outsides of the graph and not true for the inside of the graph, which you'll see here. So they're not true asymptotes. So my x-intercept, when I plug in 0 for y, would give me 1, 0. When I plug in 0 for x, I would get 0, 1, 12th. So I'm going to go ahead and plot those. So 1, 0, which already shows you it's going to have a point on that horizontal asymptote, and 0, 1, 12th, which is right here, which doesn't do a lot for me on the outsides, but it does do something for me on the inside. So if we simplify x over x squared, that's equal to 1 over x, which should give you an idea that your outsides, the intervals that are your end behavior intervals, are going to behave something like that. So they're not going to be both going the same way. They'll be going opposite ways. So for this, I would straight plug in points. So keep plugging in points where we're going to graph. So like by plug them in, I mean plug them into this equation up here so that you can see what you're going to get. So if you plug in something like right after negative 3, like negative 3.01, then go negative 3.01. Let's get out of this. Negative 3.01 in my minus 1 in my numerator, divided by negative 3.01 squared minus negative 3.01 minus 12, which would give you negative 57. So I know it is really negative then, which means that hopefully you'll be able to see that this graph is coming from way down here and is going to, it's going to start down there and come up like that. So it's going to look like that, which probably will tip you off that this side is going to be the opposite side. And look like that. Then the inside. So I would pick a point that is really close to negative 3, like negative 2.5, and see where that is. So negative 2.5 is going to give you a very high number, a large number. And then a value like 3.5 is going to give you a very negative number. So you'll be able to kind of see that this graph is going to look like that in the middle. So if we're looking at a range now, our range from negative infinity to positive infinity, there's not a value that there's not at least one x for. So our range is from negative infinity to positive infinity. Feel free to graph this on your calculator to check. This graph is increasing never, and it is decreasing on all those intervals. So negative infinity to negative 3, negative 3 to 4, and from 4 to infinity. And is it continuous? It is not continuous because there's vertical asymptotes. So if there are vertical asymptotes or holes, that means it's not a continuous function. So our asymptote behavior, since we have 2 vertical asymptotes, we are going to have 4 limits. The first one will be dealing with negative 3 and the other one with 4. So the limit of f of x as x approaches negative 3 from the left, we're going to have the limit of f of x as x approaches negative 3 from the right. We're also going to have the limit of f of x as x approaches 4 from the left, and the limit of f of x as x approaches 4 from the right. So, I think it's easiest to write all those out so I know what I'm looking at. So, as I'm approaching negative 3 from the left, my graph is going to negative infinity. As I approach it from the right, my graph is going to positive infinity. As I approach 4 from the left, my graph is going to negative infinity. And as I approach negative 4 from the right, it is going to positive infinity. And what I'm talking about there is as I'm going towards negative 3, my graph is going down from the left. As I'm going towards negative 3 from the right, my graph is going up. As I'm coming towards 4 from the left, my graph is going down. And as I'm coming towards 4 from the right, it is going up. So that is where those values are coming from. With that, my end behavior is still true end behavior, so I'm only going to have 2 of those. So the limit of f of x as x approaches negative infinity, and the limit of f of x as x approaches positive infinity. So as x approaches negative infinity, as I go to the left negative, my x value is approaching my horizontal asymptote at 0, and the same happens when I go to positive infinity, also approaching my horizontal asymptote at 0. So there is a key to this homework that is on my desk that is yellow. Feel free to use it as you go through your homework. Also feel free to use your calculator to help you with these. A lot of this test is going to be analyzing these graphs, and like if you really don't know how to do it, then that's going to be a problem for you. So use all of that, and yeah, that's all.